The QorIQ LS1012A reference design board is a compact form factor tool for evaluating LS1012A application solutions. The LS1012A RGB provides an Arduino Shield expansion connector for easy prototyping of additional components such as an NXP NFC Reader module. This video explains the kit contents and the various components of the board. Our next slide shows the list of items that are being shipped along with the QorIQ LS1012A RDB board. First is the LS1012A RDB kit enclosure, a 12V 5A AC-DC power adapter, a universal adapter, a 22-pin SATA 3 cable, a Cat6 Ethernet cable, a zip bag that contains a Wi-Fi card assembly accessory standoff with 4 nut pieces and 2 pieces of screws, a USB cable type A to Mini B, and an RS-232 serial cable. Let's have a look at the different components available on the top side view of LS1012A RDB board. The first is the LS1012A RDB processor. The LS1012A RDB board features a 64-bit ARM-v8 based processor with network packet acceleration and QorIQ trust architecture security capabilities. The LS1012A features line rate networking performance at 1 watt typical power. Next is the Spi interface. The board supports on-board 512 megabit Spi flash memory. There are 2 virtual banks on the RDB. Bank 1 is available at the bottom of the board. This is Bank 2. Next is the Spi emulator that provides off-board Spi emulation support. The next are the 3 SerDes lanes available on an LS1012A RDB board with a speed of up to 6 gigabit per second. The lane A supports SGMI1G5. The lane B supports 1/2 mini PCIe slot that can feature PCIe Gen 1 or 2 cards. And the lane C supports 1 SATA connector with 22-pin power and signal connector. Apart from these 3 SerDes lanes, the LS1012A RDB also supports one USB 3.0 super speed lane. Next is Arduino. Arduino connectors supports I2C, UART, Spi, audio through Spi controller and 6 dedicated GPIOs. Now let us have a look at the I2C component. The board supports one I2C bus with connectivity to various devices such as a 3-axis digital angular rate gyroscope, 6-axis sensor with integrated linear accelerometer and magnetometer, and an LTC4155 battery charger with power manager, which is available at the bottom side of the board near J2 connector. The battery charger along with the power manager is used to power the board in battery-backed USB powered mode. If you want to connect any external devices on I2C, it can be connected via Arduino or the dedicated I2C header. Next is the UART interface. UART1 is used as console on the board. Based on the dip switch settings, UART1 can be accessed from either a UART header which supports RS-232 levels and a debug USB port. Also, the board supports one Spi to dual UART bridge for UART connectivity to Arduino. The board also supports USB 3 type AB connector. Other than this, the board also provides debug features such as ARM Cortex 10-pin JTAG connector for LS1012A, a CMSIS tap through K22 microcontroller, which as explained earlier can also be used as a port for UART console, and a SWD connector for KW41. Please note KW41 will be available in future revisions of the board. Next is the power supply. LS1012A RDB can be powered up via an external 12-volt DC power adapter, a PoE-enabled Ethernet port, and a battery-backed USB port. Now, this is the power switch that toggles the board power. The reset switch is used to reset the LS1012A and its peripherals by asserting reset. Next is the SDHC interface. The LS1012A RDB board supports two SDHC interfaces, SDHC1 and SDHC2. The SDHC2 supports SDIO Wi-Fi module and one eMMC memory at the bottom side of the board. The SDHC1 connector can support SD and SDIO cards. Now let's look at the other components available at the bottom side of the board. One 16-bit DDR3L SDRAM memory. Next is the Ethernet component. The board has two 1 Gbps Ethernet interfaces. There are two PHYs, RGMI and SGMI. This is the RGMI based Ethernet port and this is the SGMI based Ethernet port. For more details on LS1012 reference design board, please visit nxp.com or you may also contact your local field representative. Thank you for watching this demo.